this way. Your life's a joke, you broke. Your love life's
Ma, the meatloaf! Oh, hey, Dad. Hey, since you're here, me and my friends are about to study protein structure. Hey, look at John.
This is the primary structure of a protein group. It is made up of many different amino acids like glycine, proline, and threonine. The protein structure is not made up by the amino acid groups, but by genetic material. And it is a unique series of labeled amino acids. Each amino acid has a nitrogen group, two carbon groups, a carboxyl group, and an R group as well. Since many amino acid groups are very large, this is just a small view of transthyretin. It's a 3 amino acid groups of it, and transthyretin is a globular blood protein that transports vitamin A. So one last thing about the primary structure of proteins is that it dictates the secondary and tertiary structure of a protein due to the chemical nature of the backbone and the side groups.
Hey, kids. I'm Scott. You just heard about primary structure, but I'm here to talk to you about secondary structure. And it's not that complicated, don't get scared. So let's take a look. In proteins, there are many coils and folds that make up the overall shape of the protein, and this is called secondary structure. Hydrogen bonds are found in many parts of the polypeptide backbone. This is due to the partial negative charge of oxygen and the partial positive charge of nitrogen. Usually, hydrogen bonds are weak, but due to their abundance in the chain, they help support that part of the protein. There's two major parts of secondary structure, one being the A helix and two being the B-pleated sheet. The next aspect of secondary structure is the B-pleated sheet. B-pleated sheet is made up of many polypeptide chains, otherwise known as B strands, and are connected by hydrogen bonds, as you can see. B-pleated sheets make up the core of many globular and fibrous proteins.
But wait, there's more.
More? I don't know how much more I can take.
Whoa, man, you're not you when you don't have your protein.
That's right, everyone needs their fair share of protein. The shape is also reinforced by hydrophobic interactions and the disulfide bridges. While the secondary structure of a protein is made up by the backbone constituents, the tertiary structure is made up by the interactions of the side chains. And that's all you need to know about tertiary structure.
Well, you got pretty far, haven't you? Not that scary, huh? Well, there's one more thing that we gotta get through. Don't worry. It's quaternary structure. And you're gonna learn all about that right now.
Gee whiz, this isn't that bad. I think I can handle the fourth step. Our last stage is the quaternary structure. An example of the quaternary structure is transthyretin protein, which is made of 4 identical polypeptides, which make the protein itself. So remember, kids, association of multiple polypeptides form functional proteins.
Because most diseases result from improper protein function, by studying the intercellular metabolism of protein function, we can find hopes in finding cures for such diseases.
Well, hey, look, you're all done. Not too bad, right? I mean, feels like just yesterday I was just teaching you about bio. Now you know all about protein structure. I mean, it really hits home. So, I just want to let you know, science is cool. So, you know what? I say we go enjoy ourselves some meatloaf. Let's go, Dad.